Hello guys, in this video I'm going to show you how to solve count of subset sum using a bottom-up approach. Right. So in the last video we've solved this one in top-down approach. With top-down approach, right, we use recursions starting from original questions and break it down recursively into smaller problems. Then we combine the results from subproblems. But for bottom-up approach, when I use a two-dimensional table and as and start to build up uh, from bottom, right? We start from small problems first, then combine small problems into bigger problem, and eventually we will solve our original questions using previously solved subproblems, previously solved small problems, right? So let's go through the uh, problem statement once again. Okay, so let's go through the problem statement once again. Given a set of positive numbers, find the total number of subsets whose sums is equal to a given number s. Right, so two pieces of arguments. Numbers is a list of numbers, positive numbers, and the target is a sum is a given number s here. Right, we need to count the subset to sum up to s. So for this given input, the expected result is 3, which means there are 3 subsets that sum up to 4. Right? The target sum is 4, which are 1, 1, 2, 1, 3, and 1, 3. Note that we have two similar sets, 1, 3, because we have two ones in our input, right? So 2, 1, which means this one go with 3, form a one subset, and this one form with 3 form another subset, right? Okay, so let's start with our two-dimensional table first. What is the row and what is the column? The column, like as every problem in this dynamic programming category, the column would be starting from 0 to s, right? 1, 2, 3, 4. 0, 1, 2, 3, 4, right? Okay. And the row, each row will represent a number from the number list, right? From this input, right? So we have 4 rows in total, right? For each row, we're gonna process one number from our we'll consider one number from our input, right? So our goals now is to fill up our table, right? From left to right, from top to bottom, and each cells it will be the answers for the sub problem, right? So the final problem is find the total number of subsets whose sums is equal to a given number s. So our sub problem would be find the total. For example, here in this sub problem, it would be find the total number of subsets whose sum up to given number 0, and considering the set of positive numbers including only 1, right? So for x we only consider 1, right? So let's another subproblem would be, for example, here in this cell. For example, our goal is to find the total subset, sum up to 0, considering a set of positive numbers which are 1 all the way from 2 to 1, right? 2, 1, and 1, so on and so forth. So as we filling up our tables, we will end up these positions. The last, the uh, bottom bottom right corner, which is would be the answer for our original questions, which is considering a set of positive numbers which are from 3 all the way to 1. Find the total subsets, right? That sum up to 4, right? Okay, that is basically how it works. So let's start filling up the table. So for dynamic programming with bottom-up approach, we need the we need some assumptions. Uh, on small problems, on some first problems. In our case, it would be the first, because if we don't have assumptions, some first assumptions, how we can start to fill up our table? Because for each cells in our table, it will depends on the previously solved problem, right? So our first assumption would be the first column, which is answers for problems, like for find the total number subset. Let's sum up to 0, right? Sum up to 0 here, given this input, right? So the answer would be, what would be the answer here? It would be O1 here, right? Why this one here? Because in order to find a subset that sum up to 0 from any given input, you always have only one choice, which is a empty subset, right? One choice here is a empty subset, right? So the other assumption here would be the first row, right? where we only consider one, right? So because we only have one in our pocket, we only have one in our pocket. So the only choice here, so in order to find a subset that sum up to any of these numbers, we only have a choice to pick one, right? So it is obvious that the only case that we can find a the only case that we can find a subset that sum up to a target number here is this case, where the number that we're considering here, which is 1, is equal to uh, the target number, right? So in that case, we have the choice to pick one, to pick the first number here, right? So if the number that we're considering is equal to target number, we have the choice to pick it, right? So the total of subset is 1. Okay, there's one possibility. For any other cells in this uh, in the first row, it will be obvious that the answer will be 0, because we have no choice. We have only one choice in the in this cell. For any other cells, there's no uh, number of subsets sum up to the target number here, the target sum here. Okay, so here is our base case that will depends on when we start solving, start filling up a table. So let's start from here and asking questions. How many subsets do we have? The sum up to 1, given uh, the input a set of positive numbers which are 1 and 1. So for each cell we have 2 choice, all right. So the first choice would be to select the uh, the current row, the number at the current row, which is 1. And the second choice would be skip the number at the current row, right? So we don't select this number, right? So if we don't select one, if we don't select one, then the answer would can be found in the cell right above, right? Which is given considering this input, which is not including the one here, right? Considering this input, how many total number of subsets that sum up to 1? So the answer is 1. So if we don't select this one here, we can find if we don't select one here, we can find one subset, right? But what if I do select one here? If I do select one here, if I do select one here, I can take out one here from our target sum, right? So we are left with 0, right? So again, we look at a smaller problem, which is because we take one, so we don't consider this a row anymore. We will go up one row. Right, so because we take one, so we take out one from target sum, we are left with 0, and our target, our sub question would be how many subsets can we find that sum up to 0 using this given input, which is 1. So the answer is 1, right? So combining two smaller problems, which is either take one or skip one. Take one or skip one. For each case, we have for each case we can find one subset, right? So it means for both cases, we will have two we will have two subsets. We can find two subsets, right? Out of the two possibility, right? Okay, move on to here. The question would be how many subsets that we can find sum up to 2 using the given input of 1 and 1, right? So so again, we have two choices here, which is either take one here or skip one. If we skip one, the answer will be can be found here, right above, which is how many subsets that sum up to the same target sum, which is 2 here, using only one here, not including one here. So the answer is 0. We cannot find it. But so for the first possibility, which is the first choice, which is skip one, we have not found any subsets, right? But for the case we select one here, how many subsets we can find that sum up to 2 here? So if I select one, it means I will take out one from the target sum here, 2, we are left with 1, right? The new target sum is 1, but not including this current number, right? Because we already took it, so it is here, right? Target sum is 1, only considering 1, so there are 1 subsets, right? Combining the two smaller problems, which is 0 and 1, so they are 1, right? Okay, so uh, how many subsets we can find that sum up to 3 using this given input 1 and 1? It's obviously that we cannot find, right? We cannot, there's no any subsets that sum up to 3, right? Because even when we add up all the numbers, which is 1 and 1, we have 2, is still less than 3. So let's quickly fill up it here. Is 0. Same here, 0. So again, come back with this column. The target sum is 1. Two choices, either take 2 or skip 2. If I skip 2, the answer will be here, which is 2 subsets, right? We can find 2 subsets. But if we take 2, which is we cannot, because our target sum is 1, I cannot select 2, right? It will be just over our target. So the answer we know we cannot find any subsets if we take 2. So 0 plus 2 is 2. Next one would be, okay, if I select 2, if I skip 2, I can find 1 subset. But if I select 2, I will take out 2 from the target sum, left with 0, right? But not including 2 here, so it will be here 1, right? So 1 subset if I take 2, and 1 subset if I skip 2, so it will be 2 in total. Next, 3. If I skip 2, it will be 0 subsets. If I take 2, I will take out 2 from the target sum. I left with 1. But I don't want to include 2 here, so it will be here. So there are 2, right? So 2 subsets if I take 2, and 0 subset if I skip 2. So it will be 2 in total. Next, 4. If I skip 2, it's 0 subsets. But if I take 2, it will be 4 minus 2 is 2, right? And I don't want to include 2 anymore, so it will be here. So I can find 1 subset, right? So combining 2 cases, that would be 1 in total. Next one, skip 3 and take 3. We cannot take 3 here, right? Our target sum is 1. So I can only take I can only skip 3, so it will be 2. Next, if I skip 3, it will be 2. I cannot take 3 because our target sum is 2, so that will be 2 in total. 3 here, 2 subset if I skip 3 here. But if I take 3, which is something we can, because yeah, it's still less than or equal to our target sum. So that would be me taking out 3 from 3 here. So we're left with a 0, our target sum is 0, but we don't want to include 3. So there's 1 subset. So combining 2 cases, 1 plus 2 is 3. Okay, next. 4. Target sum is 4. I have 2 choices. If I skip 3 here, there will be one subset, right? But if I take three, uh, I will take out 3 from the target sum 4, left with 1, right? So it will be here. Target sum is 1, but not including 3. So it will be here 2. So combining two cases, 2 plus 1 is 3. So finally, we've finished filling up our table. So it means the total of subsets that sum up to 4 using all the number from our input, right? The answer would be 3. There are 3 subsets, right? So let's try to code it out. For this kind of program, we need to a 2-dimensional tables. So I will abstract it out into create magic. Right? We need to provide the number of rows and columns. The number of rows will be just the size of our input, right? Nums, not length. And the number of columns would be here, for example, SE4, then we need 5 columns, right? Including 0 here. So it will be target sum plus 1. With matrix will return a 2-dimensional table. I call it DP. Stand for dynamic programming. Okay. So we want to make assumptions as I described earlier. So okay, let's build up our create magic here. Function create magic. We need to provide rows and columns. Okay, I'll return an array of rows first. Arrays that had rows element. I will fill up with no, then map each element with another array, right, of side columns. And I will fill up with 0, I guess. Okay, so let's double check it here. Create magic. 3 and 4, right? 3 rows, right, and 4 columns. Correct. So my assumptions would be first row, first column first, right? So for each row of DP, right, I will update the row of the here the first item in each row, right? It will be 1, right? So okay, the first row. Okay, the first row would be DP first row, and we want a column that equal to the first number of our input. So it would be nums at index 0 also. It will be 1. Okay, start filling up our magic. Let wanna start at row of 1 at the second row, index 1, right? Row less than rows and row cost plus all the way to the end. Right. Column equal to 1, column less than columns here. Okay, so we need to fill for each iteration here, we need to fill up um, what is that, dp at row and column. So the current number that we are considering is current number. The current number is nums at index row. Okay, two choice. Take kernel. Now skip kernel first and take kernel. So if I will combine two choices. So if I skip kernel, none of subset. If skip kernel would be the cell right above, which is cell at the same column, but one row above, right? Same column, one row above would be row minus one, and same column would be column. Okay, if I take none, actually we can because each cell start with 0, right? So I can just add it up to our cell. So dp row and column. I add up the number of subsets from subproblems here. If I skip the current number, or if I take the current number, which is something I should check, right? Only if the only if the current number, the column is greater than or equal to the current number, right? Which is nums at kernel. Then I can take this one. So if I take this one, the answer would be not including current number, which is dp row minus one, and because I take this one out, so I will take the current number out of the column, right? So this we will store in. I will add up these two, same here. I will add up it here. So it's like we are combining the result of two cases. either when we skip the current number and or we take the current number here. So at the end, I will just return dp at rows minus 1 and columns minus 1. I think that is it. Just 15 and 5. Oops, my mistakes. Okay, it works really. So that is it. I think let's double check it again. Okay, awesome. So that is it for this video. Count the subset sum with dynamic programming using bottom-up approach. Right. So thanks for watching. See you on the next video.